Of course, text isn't very interesting, so we actually want to be able to like draw things, right? That's really more what probably most artists and designers would want to do. I mean, text can be useful, but probably not what most are aiming at. So instead of text, let's go ahead and get rid of that. And let's make, instead, a background. And then inside of the parentheses, we need to give it some parameters, right? So what is the color of that background going to be? There are a couple different ways that we can define the background color, but I prefer to use hex values, which is the colors that you typically find on the internet. I think it's a little bit easier way and a little bit more standard way to represent colors, especially nowadays in like the digital medium. So to do that, we're going to go ahead and create some quotes. And we need to use a hashtag, and then we need to put a value in for red, green, and blue. I'm going to create a light gray color, which means that I want all of my red, green, and blue values to be fairly high, which means that they're going to be approaching F. So what that means is in hexadecimal, you don't have 0 through 9, you have 0 through F. So it's 16 total values. In the way that we normally think in the decimal system, which is 10 total values from 0 to 9. So if we want a shade of gray, all three need to be the same amount, the same value for red, green, and blue. And then if we want it to be on the lighter side, it needs to be closer towards the maximum, closer towards having full brightness, which would be F. So I'm going to go with, I think, C, C, C. F, F, F would be pure white, and 0, 0, 0 would be pure black. So no brightness as far as the 0, 0, 0 goes, and full brightness as far as the F, F, F goes. So I'm going to go ahead and save it, and we can go over here and we can refresh it, make sure it worked. There we go, we've got a gray background. And then let's start looking at shapes a little bit. So before we do a shape, let's do maybe a point and then a line, and then we can combine those different ideas into actually polygons, right? So for a point, we write basically point. We open our parentheses because it is a function. We end the statement with a semicolon, and then inside of the parentheses we need to have some sort of argument, some sort of numbers that we're putting in that's telling it where to put that point. We could just do 200, 200. Oh, there we go. Can you see it? There's this little bitty point right there. Not super interesting, but it worked. If we want to make another point, maybe point, we'll type it again, maybe at 250 by maybe 75. All right. Oh, it's a little bit higher than I expected. It's way up here, right? So now we have 2 points. So how do we put a line between those points? So to do a line, instead of point, we type line, parentheses, semicolon. Inside of the parentheses, we once again give it the coordinates for the two different points. So if I want to connect my point that's at 200, 200 to my point that's at 250, 75, then those are the values I need to put in. So 200, 200, and then 250, 75. And now I have a line between those 2 points. Now I actually don't need these points anymore because this line is starting and stopping at those points anyway. So if I delete these points, the line will still be there, right? So looks basically the same. If we combine points and lines, we should be able to make shapes as well, right? So if it is a three-sided thing, then it's some sort of triangle, right? If it's more than that, it might be a quadrilateral or a polygon or something like that. So we can do triangle, right? And then inside of here, that means I'm going to need 3 different sets of coordinates. So maybe we stick with our 200, 200, or you know what, maybe I don't. Maybe I do 190, 190, and then this one we can do 240, 65, and then I need one more point. What will my last one be at? Maybe my last one will be like 300, 300. Save, refresh. There we go. So now we have a triangle. Now notice that my triangle is almost completely blocking my line, right? So when we are writing code, especially like for the web, it executes basically down the program. So it's making the background first, and then the line, and then this triangle on top. So if we want the line on top, we just need to switch the order, right? So draw the triangle first, then draw the line. There we go. And if I want a quadrilateral, that's a little challenging to spell. Luckily, you don't have to spell the whole thing. You just write quad, and then now we need to put in 4 sets of values, right? So maybe I do 180, 180, and then maybe 230, 55, and then maybe this last one I do 290. No, I'm gonna go make it larger. 310, 310. Oh wait, we actually need one more because that would be a triangle. So what would my last set be? Maybe 160, 200. Save and refresh. There we go. That's technically a quadrilateral. We don't typically think of it that way, but it is one. It is one. Now once again, I don't like that it's on top, so I can move it underneath by putting it higher up in the code. Right? There we go. I like that a bit better. And there's a whole other series of shapes that we can also make. So we can make a rectangle. So a rectangle is going to look a little different, right? I mean, a rectangle is a quadrilateral, right? But it's a very specific one. It's one where the sides are parallel to each other, right? And the corners should be 90-degree angles. So for this, we don't have to give as many points. We only really have to define 2 points, because the other points are going to be defined by those parallel lines and those 90-degree angles. So for a rectangle, we only need 2 sets of points, basically the starting point, and it will figure out the other 2 for us. So if we do maybe 170, 170 by, maybe I want to do, what do I want to do? Maybe 230 by 310. And if I save it and I refresh, there we go. It's a little bit bigger than my actual canvases. So how did that happen? 230, 310. So the second set of values actually aren't the ending point. It's how much on the width and on the height it's going to go. Right, so if we make this like 80 by 80, there we go, we should have a square. There we go. Well, it's a little small. Maybe let's try 180 by 180. Better, right? So the starting coordinate and then the value of the width and the height. We can also do ellipses, which are, you know, circles that may or may not be a perfect circle. So that's not too challenging either. So ellipse, and then open parentheses, we need a semicolon, and then inside of here we also need a set of values again. So our values are going to be the starting point, and then once again sort of that width and height. So maybe for this one I'll do 100, 100, and then let's try doing 50 by 100. So if I save and I refresh, you can see, there we go. So it's starting at 100 to 100, and then the width is that 50 and the height is that 100, right? If you want to do partial circles, that's pretty easy in P5. So for a partial circle, we call that an arc. And then inside of here, the values get a little bit more complex. So let's say that we want this to be at, maybe we'll make this at 100, and then maybe we make the other one at 300. And then maybe let's make it just a circle for right now. And then this last one is how much of the arc it's going to show. So I think radians are pretty easy to read. And if we do 90, right? And then we take a look at that. Oh, I missed a value. There we go. So 5 values and then radians. So if we refresh, there we go. And you can sort of play with these values to hopefully understand a little better what they do, right? So it sort of defines where that arc starts, right? And then where it finishes. And you could also use actually radians for both of these If you wanted to, that might be easier. Or you could use just a straight integer instead for both and see what you think about that. I think using radians makes it a little bit sort of easier to visualize what you're doing though, because then it's sort of clear that these are both related to the actual part of the arc. The last part that I'd like to show you for this is to actually add in some color. So to add in color, we can use the fill function, and basically we just write fill and then parentheses and then semicolon, of course, and inside of here we can put in another hex value. So here maybe I want the ellipse to be black, maybe I want the arc to be red. So if I want the arc to be red, then this first value needs to be very bright, very high. If I want the rectangle to be green, then the middle value needs to be very bright. And maybe I want everything else to be blue, in which case that last value is very bright. So red, green, blue, that's sort of how the colors work. And to get any other color, you combine different amounts of these. So if we save it and we refresh it, there we go, now we've got colors. Just like we modified the color of the objects, we can also change the little strokes around them, right? So we could do like stroke weight, and in here we can put a value, and we can also do no stroke if we don't want there to be a stroke at all. And we can choose the color of the stroke by just writing stroke and then the color value. So maybe I want this to be magenta, so 0FF. And if we save and refresh, there you go. Ooh, wait, I did cyan. Magenta would be F0F. There we go, now we have magenta. If we add one more value on these hex codes, that'll give us alpha, which is transparency. So if I do F0F, and maybe I add an A here, and then I do F00, and maybe I add a 4 here, we can see how that changes things. There we go. So we can see here, this fill at 4 is pretty transparent, right? So as that fill approaches 0 on the alpha, it gets more and more invisible. 0 is completely invisible. And as the other one approaches F, it becomes less and less transparent, right? So at F, it is absolutely not transparent at all. It's like 0% transparent, right? And if we put values somewhere in the middle, then of course you're somewhere in the middle, right? So by default, things are at full opacity, 0 transparency, right? And if you don't put a value in there at all, then that's what you'll get. So that should be a good amount of things to play with for this video. Now right now we're just drawing, right? And that's a very minute amount that you can do with p5.js. If this was all you could do, then you might as well just play with SVG. But the part that really becomes interesting is when you start adding like animation or interactivity or replication or some of those sorts of things. So play with that a little bit, get the hang of it, and then we'll move on to where you can actually create things that are really dynamic and interactive.